Hi students, so now we will be solving this particular problem which goes as integration of 1 plus tan square x divided by 1 minus tan square x into dx. Okay, so I hope you remember that, at least this part you remember that in the 11th grade when we deal with trigonometry, all right, we come across three possible formulas of cos of 2x, all right. And one of the formulas of cos of 2x is nothing but 1 plus tan square x divided by 1 minus tan square x. I don't know if you remember or not. We will be dealing with, I'm sorry, this is something that I wrote the reciprocal of. This is minus and this is plus. This is something that we deal in the 11th grade, but in case you are not aware of it, we will also be dealing with it in our other module of trigonometry. But as of now, you can remember that there are three basic ways by which we actually describe cos 2x, 3 or 4 maybe. All right, roughly I think it's 3 or 4. And one of the ways is like expressing cos x in the form of tan x. All right, so as you can see that since we know about this formula, which is nothing but cos 2x equal to 1 minus tan square x divided by 1 plus tan square x, now we can directly apply this. All right, in this particular problem, if we directly write it as integration of cos 2x dx, because this thing can be expressed in like cos 2x can be expressed like this. Is it right? No, it is not. This is not right. I will have to write this as integration of 1 by cos 2x into dx. I hope you understand why. Because in our actual problem, we don't have the plus sign in the denominator and the negative in the numerator. Okay, we have the opposite of it. Okay, so definitely since we have opposite here of what is the actual form, so when we take if I take cos 1 by cos 2x, this also becomes 1 by, and so we get 1 plus tan square x in the numerator and 1 minus tan square x in the denominator. I hope you know all these very basic mathematical operations. Okay, now what next? We know that 1 by cos x is nothing but sec 2x or sec x, whatever the angle is. Here angle is 2x, so we have written 2x here. And few videos earlier we studied about the formula of sec x, right? Integration of sec x dx, which is nothing but log of mod. All right, log of mod sec 2x plus tan of 2x, this, remember, whole divided by 2 plus c. All right, so ultimately what we get here is nothing but log of sec 2x plus tan 2x divided by 2 plus c. One of the most important things that you have to always look for is the angle. All right, the kind of angle that is given in the particular question that you are solving, that in itself is going to decide what will be the solution of the integration problem. Because if you just write log of sec 2x plus log mod of sec 2x plus tan 2x plus c here, you will get the wrong answer because you did not consider the constant in your denominator. Here we don't have x as our angle, but we have 2x as our angle, and these things do matter. All right, things change by quite a great extent when you overlook these kinds of small things that are given in the question. All right, so I hope you got this very easy problem. It was just a game of one formula and you are there in your answer. Now the next problem that we will be solving is also very easy. It is nothing but integration of sine square x minus cos square x divided by sine x cos x into dx. We have also used this formula before. All right, I hope you know that there is a formula of cos 2x, right, which is nothing but cos square x minus sin square x, the very first formula which they teach for cos x. All right, this is the very first formula for cos that you get, and then you have 1 cos 2x with respect to cos x in terms of cos x, and one relation of cos x with respect to sin x, and one relation of cos x with respect to tan x, which we just did in the previous problem. So exactly we have 4 formulas, I think, of cos x roughly, the four most common formulas that we get to deal with. So here my task will be to take a minus sign common so that this becomes a sin square x minus of cos square x. So ultimately when we multiply this with the minus signs, we will get what is our original question only, which is nothing but cos square x minus sin square x. Why did I choose to bring it in this particular format is because so that I can replace this cos 2x in the numerator. But here instead of cos 2x, I will have to replace it by a minus cos 2x. Okay, here we had a cos 2x, right? So this is nothing but minus cos 2x equal to sin square x minus cos square x. Okay, now what next? Here in the numerator we will be putting a minus cos 2x. In the denominator we have a sin x cos x, right? So what shall we do here is we can bring it in this format, right? This is another formula of sin 2x. I hope if you remember, we have used this also, I think, many times before. I don't remember, but I hope you know that sin 2x is nothing but 2 sin x cos x. So I'm trying to bring a sin 2x in the denominator, so I multiplied it with a 2. Now as I said, you just can't forcefully induce an outsider into your problem just for the sake of solving the problem. When you induce something forcefully, it becomes an equal responsibility of yours to neutralize what extra you have taken. All right, so if I have a 2 in the numerator, in the denominator, which I have taken forcefully, then I will also have 2 in the numerator, so that the 2 and 2 gets cancelled and our original format remains the same. All right, so next what we will be doing here, minus will get outside and this will become cos 2x divided by sin 2x into dx, and this is nothing but minus 2 integration of cot 2x into dx. All right, so as we come here, we studied this particular formula few videos earlier, few lessons back. All right, cot 2x is nothing but log of mod sin 2x divided by 2 plus c, or this 2 gets cancelled and you finally have a log of mod sin x sin 2x plus c. There is a minus. Okay, so this is the final answer for this particular question. Now we will be moving on to the third question, which is again an easy question. All right, so what is our third problem here? Our third problem is integration of 1 by cos 3x minus cos x into dx. Okay, so how will we solve this particular problem? Now first, what you have to do is, whenever you get a problem, it is very important for you to look at the patterns. Okay, so first don't try to come across which formula you will apply. Okay, just don't get right into the problem that way. First try to understand what pattern the question is in and how can I simplify the pattern. Okay, so this particular question, as you can see in the denominator, again this is a concept of trigonometry. I have been consistently giving you problems which are mashed up with trigonometry and integration, just to help you ensure that how important is trigonometry, and as you will extend yourself further, you will realize that the applications of trigonometry only increase in the long run. All right, so here as you see in the denominator, we have a particular formula which is nothing but cos a minus cos b. We have cos 3x minus cos x, which is nothing but cos a minus cos b formula. If you remember, the formula of cos A minus cos B, which is nothing but minus of 2 sine of A plus B divided by 2 into sine of A minus B divided by 2. Here A is our 3x and B is our x. Alright. So now what we will be doing is we will be simply simplifying this particular thing. So what we will be getting, sine of A plus B, that is 3x plus x, which is nothing but 4x, right? So sine of 4x by 2, and this will be sine of A minus B. A is 3x, right? B is x. So 3x minus x is nothing but 2x by 2. 2 is already there in the denominator. So after doing all the cancellation, we will be getting 2x here and we will be getting a sine x here. Alright. Now, what is the next step that we will be performing? So we get a minus 2 sine 2x into sine x. The next step is that in this place of 1, we will replace it with the relation that we have already done before, that sine squared theta plus cos squared theta equal to 1. Here it's x, so sine squared x plus cos squared x equals to 1, right? So I can replace this 1 by sine squared x plus cos squared x, okay? So let me do that. Sine squared x plus cos squared x divided by, we did this simplification, which is nothing but minus 2 sine 2x into sine of x. All right. Or maybe if you want, then you can also, like, what you can do is you can break the denominator. Here in place of sine 2x, you can all take the minus 2 outside for convenience. Okay. Alright, let me cancel this. See, take the minus 2 outside. Then in the numerator, we will be having this one, as I told you. And in the denominator, what we will be having is minus 2, we took it outside. Sine 2x is nothing but 2 sine x cos x into sine x, right? Now we will take this 2 outside. So we will be now separating this entire thing. Okay, how will we be separating this entire thing? Integration of sine square x divided by 2 sine square x into cos x into dx, alright, plus integration of cos square x divided by 2, sorry, 2 has already been taken common, that is why the denominator is 4. So we will be just having sine square x into cos x here in the denominator dx. Alright. So now after simplifying further, we can see that sine square x get cancelled. And in the place of 1 by cos x, we will be having integration of sec x into dx plus what we will be having here, this cos square x, 1 cos x will get cancelled, right? Cos square x divided by sine square x into cos x. So 1 cos x will get cancelled in the numerator. So we will be left with cos x by sine x into 1 by sine x. So I can basically write this as integration of cot x into cosec x into dx, right? Now that we have come here, it is very easy. Why? Because we have a direct formula. All right. Let me explain this part to you, because this part was actually cut entirely. So what I did here is I just replaced this 1, all right, this 1 by sine square x plus cos square x, because we know this particular relation, that sine square theta plus cos square theta equal to 1, all right. So just based upon this relation only, what I did is I put sine square x plus cos square x, okay. And in the denominator, what I did is essentially, I had a minus, we replaced this part, right? We replaced this cos 3x minus cos x by this. All right. So in the place of sine 2x, I replaced it by 2 sine x cos x. Okay. Also, I took this 2 common outside of the integration sign. So when I took 2 outside of the integration sign, it became minus 1 by 4. And inside of the integration sign, I just did nothing. I separated the two terms, sine square x by the denominator, cos square x by the denominator. And then this sine square x got cancelled. So ultimately 1 by cos x is nothing but sec x. And from here, as you can see, cos square x divided by sine square x into cos x. So 1 cos x from denominator and numerator gets cancelled. So we are left with 1 cos x in the numerator. And in the denominator, we have 2 sine x which we separated. Alright. Sine square x we have, 1 sine x goes here and 1 sine x we have taken separately. So this becomes a cot x and this becomes a cosec x. Alright. And this is equal to nothing but minus of 1 by 4, this part. Now you have to simply integrate it, and you know what the integration of sec x dx is, right? What is the integration of sec x dx? The integration of sec x dx is nothing but log of mod sec x plus tan x, right? This will be minus, because integration of cot x cosec x is nothing but minus cosec x plus c. So the final answer is minus 1 by 4. Final answer is minus 1 by 4, all right, into log of sec x plus tan x, log of mod of sec x plus tan x minus cosec x plus c. All right. I hope you understood this middle part. I have explained that quite number of times. Also the middle part, I think this sum is very, very easy. All right. This particular problem is very easy. It doesn't require this much of an explanation, except the fact that you should identify that here a direct trigonometric formula has been used. All the things that have been done after that is nothing but simply very easy things, right? Like replacing 1 by sine square x plus cos square x. This doesn't require any explanation, right? Or breaking this sine 2x into 2 sine x cos x right here doesn't need any explanation. Always try to always, bring the constant outside of the integration sign. Okay. Now here we had minus 2, right? Here we had a minus 2, which I actually brought out of the integration sign. Once you do that, what happens is your sum looks a bit neat, your step looks a bit neat, else it looks very very shabby. Okay, if minus 2 is inside, then there will be another 2, so it will be a bit confusing. So try and push the constants outside of the integration sign. Try to make your solutions very crisp, very neat and very clean. This is why I give this much of explanation for this simpler problem. I could have just told you up till here and left it, but I did not do that. I want to explain each and every step to you so that this is something that you can ace at. All right. So if you really like my video, then please don't forget to like, share, subscribe and hit the notification bell icon for more of such exciting content. All right. See you in the next video.